This is Math 200. We're looking at Chapter 5, specifically 5.3, and that is page 4 in your note packet, Chapter 5 note packet. So let's jump in. We're multiplying here, So when you have 3x squared times negative 2x, there's no distributive property here. This one, number 2, that has the distributive property because you have two unlike terms inside of the parentheses. Here, it's just a monomial times a monomial. So you can reorder it. And remember, x is actually x to the first, all right? So now I do negative 2 times 3 is negative 6, and then x squared times x to the first. Like bases add exponents, so 2 plus 1 is 3, so x to the third. And we're done. This one, we do the distributive property, as I mentioned. 4x times 4x to the third, that's 16. X to the fourth, remember there's a 1 there. And 4x times 8 is 32x. Interesting question that somebody asked. They're like, wait. We can't multiply 4x times an 8 because those are unlike terms. Not true. You can multiply anything with anything else. It doesn't have to be like terms. You can take x times y. It doesn't matter. Then it's just xy. All right? It's adding and subtracting. So since that's 16x to the fourth and that's 32x, I can't add or subtract it unless it's the exact same variable with the exact same power. But multiplying, anything you want to multiply, you can multiply. So here we are. Negative 10, x to the fourth, negative 35, x to the third, because remember there's a 1 there, and positive 10, x to the second. Okay. So now we have a binomial times a binomial, and basically what we're going to do with that is just what we did here with the distributive property, but we're going to do it twice. So we're going to do y times y and y times 7, so that's y squared plus 7y. And then we're going to do 5 times y and 5 times 7, and that's going to be 5y plus 35. And then we're going to combine like terms. Again, I had a question earlier about, well, wait, that should be 12y squared. No. When you add, they have to be like terms, so they both have a y, and then it just stays y, and just the coefficient, just the number in front changes. All right? Okay, and so this is tricky because it's a to the first. So a to the first times a to the third, a to the fourth. A to the first times negative 3a squared, negative 3a to the third. A to the first times 7 is 7a. And now we do the same thing with the 2. We go 2 times a cubed, 2a cubed. 2 times negative 3, negative 6a squared. 2 times 7, 14. And now we look for like terms, and there's only like terms here and here. That's the only one that's like terms. So a to the fourth stays a to the fourth. We combine those. A negative 3 and a positive 2 is a negative 1. I don't really care if you put the 1 there. Some math teachers get really uptight about it if you have negative 1a cubed instead of just negative a cubed. I don't really care, but be warned in the future, they might care. And I tried doing that on Newton, and it didn't care if you put the 1 there. So minus 6a squared. So I'm going in descending order, 4, 3, 2, and now just a 7a. And then plus 14. And you might want to like cancel them out as you add them together. That might be a technique to use so that you don't forget anything. Like, so you'd write down e to the fourth and then cross it off. And then you'd combine those like terms and put -1 and then cross them off. And then you look around for the next highest power thing, write it down, cross it off, write it down, cross it off, and then write it down, cross it off. And then when you look across, everything's crossed off. So when it gets a little more blah like that, you might want to, you know, explore some technique to kind of organize so you don't forget a number somewhere. Okay, so now we're on to, still number 7 on here, but that one is a bigger one. So look, I'm going to show 2 techniques on this. We've got a binomial times a trinomial. And so I'm going to show you 2 different ways to do this. We're going to go just the distributive property twice. And so what that looks like, we get 2y squared times y squared. That is 2y to the 4th plus 6y to the 3rd plus 8y squared. And then plus 5y squared plus 15y plus 20. All right, so lots of pluses, all pluses. And now not everything can, there's only one set of like terms here. We've got those 2 as like terms. So we combine them. And we're done. So that's one way to do it. Another way to do it, and maybe not on this particular one because it wasn't that hard. It wasn't like, if this would have been 2y squared plus 5y, there would have been more things to combine like terms. But you can, I've seen this already where you kind of set it up like a Punnett square, like 2y squared there, 5 there. It's just a way to organize it. You basically put everything in its own little compartment here. So y squared, 3y, and 4 go across that line. And then 2y squared and 5 go across that line. If there's a minus, if it would have been minus, you just tack the negative onto it, okay? And now what you do is the ones that match up, you multiply. So this is 2y4, this is 6y3, this is 8y2, this is 5y squared, this is 15y, and that is 20. And then you look for matches. This one happens to match that one. But now they're all kind of in a little compartment, and so then you write them down in descending order. It's just a different way to do it. I've had some students in the past really swear by it. They liked it. They did it every time. And I've had most students are just like, yeah, I wouldn't do it. This wasn't that hard to you know, justify all that extra work, if you will. I'll bust this out. If it's like a trinomial times a trinomial, when it gets to be like 9 things, it's maybe a little easier to find when they're in a box and you just take them and, you know, figure out what's like terms and add them up. But yeah, not usually. Never a binomial do I do that technique. All right. So now you know. You do not have to use any special on the tests and stuff. They're not going to say, you gotta do it this way, you gotta do it that way. So you can do it however you want. FOIL for center or last, that's an acronym. I'll show you what it means. I think we kind of went a little overboard with this in the world of mathematics. At the end of the day, it is the distributive property twice, just how I explained it on the other problem, but FOIL means first times first, so we call that F. Outer is the O. So now let's examine what happened there. Look, on the one on the last page, I went Y and Y. I did the same thing. I'm multiplying it the same order. I'm just looking at it differently where I'm putting that going across the bottom. And then inner is this guy. And then last is that guy. And so again, if you think about on the last page, we went 12 times that and then 12 times that. We're doing the exact same thing. We're just kind of putting a line there. And so it kind of makes a crazy smiley face if you look at it. Like there's the smile and the nose and put little eyes right there, eyeballs. All right, but so first y squared, outer plus 4y, inner negative 12y, and last negative 48. It's the exact same thing. It's just the distributive property twice. Like I said, I think we went a little overboard with the FOIL stuff. Confused more students than we had to. All right. Let's do the second one. So that's just the same. First, outer, inner, last. 2y. So first, 21x squared, outer plus 6xy, inner minus 49xy, or yx, it doesn't matter, but pick a way and write in that method. So look, I could have said yx, but then I'd want that one to be yx. So because I wrote this one xy, I wrote this one xy also. And then last is minus 14y squared. And then combine like terms, that's those two. Okay. So now the next part here is special multipliers, meaning that some stuff happens with these multipliers. Let me show you what I'm talking about. So we've got x plus 6 quantity squared. So what that means is this. Just write it out twice, x plus 6, and then go and do what we did before, the distributive property twice. X squared plus 6x plus 6x plus 36. And then combine the middle. The reason that I like to look at it as the distributive property twice instead of FOIL is because when you get like a binomial times a trinomial, if you only know FOIL, so like number 7 on page 4, if you only know FOIL, then that throws you for a loop. You're like, I don't know what to do there because you're just doing the distributive property twice. It's just times a trinomial instead of a binomial times a binomial. So just 3 things that you distributed to and 3 things, you end up with 6 terms. And so that's why I like explaining it like this, so that if you see more difficult problems, you don't freak out. So this is the same thing. Now, if you want to do, I'll do it this way, but then I'll explain what they're talking about with the a squared plus 2ab plus b squared. I usually don't really do it that way ever. If they were going to give me like 20 problems that I had to do repetitively, I might jump on that bandwagon, but this isn't that difficult. It's not that labor intensive here. 144a squared minus 36a and minus 36a again, and then plus 9. And now I can combine those like terms. So 144a squared minus 72a plus 9. Now, another way to do this problem without doing that is you could look at what this says. This says it's equal to a squared plus 2ab plus b squared. So a squared, this whole thing is a. So 12a times 12a, 144a squared. This times this doubled. So we got 12a times negative 3 is negative 36, and then times 2 is negative 72a. And then this thing times itself, negative 3 times negative 3 is positive 9. And that's another way you can do it when it's like that. I personally prefer this. I think this is overly confusing. This is relatively easy. For me, I think, yes, visually, It's just better for me to see 6x plus 6x to get 12x, rather than just taking 6 times x is 6x and then doubling it and get 12x. But that might just be a me thing. So if you want to use the formula thing to do it every time, that's fine. I usually don't. I usually just write it out twice. Do the distributive property. And then combine the like terms. So I guess officially there is one extra step if you do it this way, but you don't have to memorize that formula. So, all right. Now the next part, this is actually important. This will be a reoccurring theme. So we're going to see this a couple of times. It's called, when you have just one sign changed in a binomial, not both signs, one sign, it's called a conjugate. Conjugate. And so when you multiply conjugates, the middle term always cancels away. And again, I had students go, oh, you guys make it so tough. Just call it an opposite. That's an opposite. It's not an opposite, because look, to be the opposite of this, this would have to be negative 2x and negative 4. Only one of the signs changed. So it's a conjugate. And so now let's look at what happens. Every time you multiply a conjugate, you get 4x squared, you get negative 8x, and then we do that, plus 8x, minus 16, and check it out. When I combine those two middle terms, poof, they're gone. Negative 8, positive 8, gone. So anytime you multiply a binomial by its conjugate, the middle term disappears. It'll go away. All right, so what do we got? 5a plus 3, 5a minus 3. Again, I had a student ask, so wait, could I just put a squared there? No, you can't, because these are different. It's not the same thing times itself. It's different because of the minus. Okay, so 5a squared minus 9. And for the last one here, I'll use their formula. I don't really like using a formula to do these. Rather just multiply it out like we've done over and over again. And then, even if you don't realize it's a conjugate to begin with, that's fine. So look, if you use the formula basically says the middle term's going to go away. So we just take this thing, multiply it by itself, 64c squared. You take this thing, multiply it by itself, 4d squared, and then you throw a subtraction sign. It's always going to be a subtraction sign between them, and you're done. Personally, I just don't mind doing it this way. Oh, dc. Minus 4d squared, and then negative 16dc, positive 16dc, those go away. And we get the exact same answer. So either way, that's fine if it's much, much easier for you to just disregard. Personally, like I said, I don't mind multiplying it out like that and watching the middle term drop out. All right? So let's take a look at the last problem on here is substituting things into functions that are not really fun. Now let's see, g of x is equal to 9x minus 3 when x is equal to, g of x, find g of negative or positive 1/3. So that's function notation. Remember function notation. So we're just going to take the 1/3, put it in where you see x, and now top times top, bottom times bottom. I don't know why I wrote a 9 there. That's 0. So g of 1/3 is 0. And that is a different way of listing a coordinate. That's x comma y. That's 1/3 comma 0. But it's just fancy, right? Because of the function. So let's look at the next one. Is f of x is equal to 2x squared plus 3x minus 4. And they want me to find f of a plus 3, okay? But when I pop in a plus 3, it's a little harder than it looks. So that minus 4 is still there. That x became that x became that. It's a plus 3 squared. So I still have to follow order of operations. I'm going to go over here and do a plus 3 times a plus 3. So a squared plus 6a plus 9 is what that is when you square it. So we've got 2 times quantity a squared plus 6a plus 9 plus 3 times quantity a plus 3 minus 4. And now I do the distributive property. And the distributive property. And I combine like terms. So 2a squared all by itself. 12a plus 3a is 15a. 18 plus 9 is 27, and then minus 4 is 23. So f of a plus 3 is 2a squared plus 15a plus 23. All right. Next video I will be doing is 5.4.